Good morning, class. So I just wanted to touch base with you guys on, there's one particular question on the 5.2 homework, which is, I believe it's homework 7 for my standalone 1324, and it's homework 10 for my co-rec. So I'm gonna just kind of walk you through the process so that you can see exactly how to work with these. And the problem is you have a graph and it only goes up to 15, but your intercepts are bigger than that. So what do you do? So up until this point, you guys have been doing where you use the cover-up method and you find the x-intercept and the y-intercept. You find those 2 points and you can graph your line. Well, to graph a line, you can plot any 2 points, all right? Any 2 points on the graph, and 2 points will make up a line. That's the definition of a line. So they don't have to be the intercepts. So what we can do is we can adjust a little bit, and the My Math Lab doesn't explain this very well. It just says graph the line. So it kind of gives you a false sense of hope that, oh, I just do it the same way. But this way, what you're going to do is you're going to pick points for X or Y within the parameters. And with this particular problem, my parameters are 15. That's as big as it goes. All right. We also know that it's going to be in the first quadrant. So let me share my screen so you can see what problem I'm looking at. That's not what I want. There we go. Okay, so this is the problem that we're looking at. These are the 3 equations, right? And this is again in section 5.2. And now you're graphing more than one line and shading. So the way you're going to do this, let me get my workspace cleaned up. I've done this before. The way you're going to do this is you're just going to graph each line individually. And I'm going to color code them. That works better for me because I can actually see what I'm doing. And remember, you are going to have to show your work. So on the next test. So make sure that you're practicing this, on graph paper or at home. So I'm just going to just walk you through each step, and I'm going to do this in different colors. So I hope that you guys can see this. So the first equation is going to be in purple. Okay, so it's going to be in purple. So as you can see, it only goes up to 15, right? That's as high as we can go. If I do my intercept and I cover the 4y up, I end up with x equals 33. Well, obviously, I don't have a 33 out here. So what that does is that should trigger in your mind, okay, I need to work within the parameters of the graph. Okay, so I'm going to take values for either X or Y, it doesn't really matter, that can be divided by 4 easily, right? So because of the way the graphs work, we need whole numbers. It won't allow you to put a point, excuse me, it won't allow you to put a point at 5.5. So you have to kind of think through, this is that critical thinking that we're trying to instill in you, especially as a business person. You have to look at a problem and go, okay, what's the easiest way to solve this problem, right? That's the beauty of math, is it teaches you how to solve. So we're going to take this x plus 4y is less than or equal to 33. So let me scroll down a little bit here. Okay, so we have x plus 4y is less than or equal to 33, okay? And I know that I only have 0 to 15 to work from. So I'm just going to replace my x with a value between 0 and 15, that when I divide by 4, right, I'm going to subtract whatever this is. When I divide by 4, I'm going to get an even number, all right? So you can pick anything. You can pick 1, you can pick 4, you can pick 5, whatever value you want. So if I pick 5, if I say x is 5, so what I'm doing is I'm establishing new points, right? I can put a point in where x is 5, all right? So if I use 5 as my, and I'm just going to use the equal sign because I don't need the less than yet. The less than and greater than signs, those are used for shading. Okay, so just solving an equation, you don't really need it. So I'm going to subtract off 5. So what I'm doing is I'm plugging in a value for 5, and then I'm going to solve for y. So I get 4y equals 28. And 28 can be divided by 4 evenly. So I get y equals 7. That is my first point. Okay, so I come over here. And with this, what you can do is you can kind of get your 2 points, because it's my math lab. You're going to get your 2 points, and then you're going to graph those 2 points. Okay, so this is my first point. So now what if I did, what if I picked 1? Right, so again, I am just randomly picking values for x that fit between 0 and 15. I could have picked 0, right? But if I picked 0, 4 doesn't go into 33 evenly. So you want to strategically pick a value that you can divide by evenly. Okay, so I take off 1. So now I get 4y equals 32. 32 is divisible by 4 evenly. So I get y equals 8. So my second point is 1 and 8. So then I come up here. I'm going to see if I can do this. I pick the point 1 and 8. So it's right there. And 5 and 7 is right there. So I'm going to color over this. So this is my first equation. Okay, there's my linear equation on the first one. Okay, so randomly pick a point for x or y. I could have picked y. X was easier because it was already by itself. So that's why I picked the value for x. But it doesn't matter which one you pick. You just have to pick a value within the parameters that is set up for you. All right, now I'm going to change colors. And my second equation is going to be orange. Okay, so 5x plus y less than or equal to 32. Oh, the other part that you want to kind of keep in mind is the, let me go back to my first one, is the idea of where is it being shaded. Okay, so since this is less than or equal to 33, you're going to use that test point. So 0 plus 4 times 0, is that less than or equal to 33? Right? So this is our test point that we always use. It makes it super easy. So I get 0 is less than or equal to 33. This is a true statement, which means I'm going to shade down here, right? There's my 0, 0 point. So I want to shade where the 0, 0 is included. Okay. So just kind of get an idea of where it's being shaded. All right. Now to the second one. Oh, come on. Okay, so 5x plus y is less than or equal to 32. Okay, so we have 5x plus y is less than or equal to 32. Okay, so again, I want to pick a value. It doesn't matter x or y. So in this case, since my y is by itself, I'm going to pick the y value. The y value, again, has to be between that 0 and 15. So when I look at this, again, I want to be able to divide by 5 evenly, right? So my value that I subtract off has to make this have a 0 or a 5 at the end. So what this is doing is it's making you tap into number sense, right? Your multiplication tables, what can be divided by 5, what can be divided by 4 on our other one. So with this one, if I pick, let's say I pick, oh, I don't know, 7 for y, right? So I'm going to pick 7 for y. So that's going to be my first point. And sometimes it's going to come up with, oh, it doesn't divide by evenly, so I have to pick another number. So if I have 5x plus 7 is equal to 32. So again, the inequality doesn't matter at this point. It only matters when you're shading. So I'm going to subtract off 7. And I get 5x equals 25. Yep. And then dividing by 5, I get x equals 5. So when x is 5, y is 7. That's my first point. It just happened. It's not the same, right? It was a coincidence, right? I didn't do that on purpose. So now I'm going to pick, let's pick another one. How about when y is 12, right? So I have 5x plus 12 is equal to 32. Now, why did I pick 12? Well, I know when I subtract 12 off of 32, I get 20. And I know 5 can be divided by 20. Okay. So let's say I'm not really thinking, and I'm going to say, okay, how about 11? Let's say y is 11. When I subtract off 11, I get 21. Well, 5 can't go into 21. So I don't want to use 11, right? 11's no good. So sometimes you just have to guess and check, see what works. But you want to use a value that when I subtract it off, I'm going to get a value that can be divided by 5 evenly. Because again, good old my math lab, which we love it, but there's some things that happen in my math lab that are a little tricky, right? So one of them is graphing, and that's why I give you unlimited access so that you can practice and practice and practice. So with this one, when x is 4, my y is 12. Okay, so I'm going to come back up to my graph. When x is 4, so I come here, when x is 4, I'm going to erase the shading just because it kind of adds too much nonsense. Okay, so when x is 4, where am I? When x is 4, y is 12, so there's my first point. And when x is 5, y is 7, so there's another point. So that is my orange, or my second equation, and you're going to pretend that that is a straight line, okay? And then the test point, right? So I want to make sure and get the test point. So I have 5 times 0 plus 0. Is that less than or equal to 32? And yes, 0 is less than or equal to 32, so that's also a true statement. So I want to include my 0, 0 point, which is right here, which means my shading goes this way. Okay, so far I have double shading here and here. Okay, so far that's where the shading is. So it's double shaded in here, right? So again, I'm going to erase the shading. And then I have to put my lines back in. So there's the purple. And here is the orange, the second one. Okay, so now I'm going to pick a new color. We'll do light blue on the green on this one. Okay, so the green one is my third one. So it's 6x plus 5y. Now notice the inequality symbol is switched. So it's greater than 46. Okay, greater than or equal to 46. Just make those little notations, you know, notice them in your mind. They're small, but they make a big difference. All right, so here we go. So this is my green one. So it was 6x plus 5y is greater than or equal to 46. Okay, so now my x and my y, they both have values that have a coefficient in front, a number in front, right? So it doesn't really matter which one you choose. You can just choose randomly different values. So let's say that I'm going to pick 1 for my x value. So why do I pick 1? Well, 6 times 1 is 6. When I divide 6 off, I'm going to get a value that 5 can be divided into evenly. Okay, so I'm strategically picking my x value so that when I subtract it off, my y value, I don't need to do that right now. So again, just using the equal sign to keep it cleaner. So I'm going to subtract 6 off from both sides. I get 5y equals 40. So 5 can go into 40 evenly. So when x is 1, my y is 8. Okay. And again, sometimes you have to do it a couple times. If I had picked 2, right? So I'll do this. If I pick 2, I'm going to randomly pick 2. Okay. So 6 times 2 plus 5y does that equals 46. So this is 12. If I subtract 12 off, you can see 46 minus 12 is 34. 5 will not go into 34 evenly, right? So 2 is not a good choice. Okay, so you try again. And that's okay. You have time. That's why you start early in the week. You don't start late. Okay, so the next one, how about if I try x is 6? I'm going to try x is 6. So 6 times 6 plus 5y is equal to 46. So 6 times 6 is 36. When I subtract 36 off, I get 10, and 5 can go into 10 evenly. So y equals 2. Okay, so again, just pick values, random values for your x. You could have done it for y and then solved for x. It doesn't matter which one. Just be consistent. I usually will pick 2 values for the same variable. So that way I know I'm using, the same type of equation. So here's my 2 points. Okay, I'm going to go ahead and do my my test point just to see where the graph is shaded. So I have 0, 6 times 0 plus 5 times 0. And at this point, right, you've done this in two different sections now, you should automatically see, okay, this side just dumps out to 0. That's why we use the 0, 0 test point, because it makes it super easy. So 0 is greater than 46. This is a false statement. So what that means, going back up to my graph, so I have 1 and 8. So I have 1 and 8 and 6 and 2. So here's the third equation. So since I have a false statement for my test point, that means I don't want, there's my 0, 0. I don't want a graph or shade on that side. I want to shade away from it. So I'm going to shade above. Okay. So if you remember, we had shade below with the orange, and we had shade below with the purple. So you can see this, let me get an opposite color. This section right here, this little triangle, that's where everything is double shaded. Okay, triple shaded. That's where it's all triple shaded. Okay, so that is why the paint can. So notice I'm only picking that paint can up once, right? I notice where it's shaded. I notice where it overlaps. Okay, and then I pick my paint can up and I put the paint can right where it's supposed to go. And you can see that because it's bounded, right? It's completely enclosed. That's a bounded region. Then I know that the paint can or the shading is going to go right in that section. Okay, and then it asks the coordinates of each corner point. Well, you can, I can't do this because this is a copy, but you can make this bigger and you can do this a couple different ways. All right, we can see that the corner points are here, 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 and here. Well, we already know what those points are. We can just read it. It's 1 and 8, right? That point right there was 1 and 8. This point right here was 5 and 7. And this point right here was 6 and 2. Now, if you look at your points, there's the 5 and 7. 5 and 7 is repeated. Okay. 1 and 8 is also repeated. 1 and 8 here and 1 and 8 here. Okay. The 6 and 2 is, it would have been repeated had we used x is 6 on this, the second line. It would have been the orange line. Okay, so you can just read, since you have exact points, you can read where your points are. The other way to do this is through a system of equations, where you are looking to see, so this is where it's important to know which line goes with which. So this is my orange line here. This is the purple line, or the first equation. And this one was the green, or the third equation. Okay, so if I'm looking for this point right here using system of equations, I'm going to do the second and the first and the second line, and I'm going to use systems of equations to do that. Okay, and then solve from there. This point right here, let me move it up a little bit. This point right here is when the green and the orange intersect. So the green and the orange. So these two right here, when those two intersect. And then this point right here is when the purple and the green intersect. So the first and the last one. Okay, and I'll do a separate video on how to find, well, you already have the videos on system of equations. Okay, that's it. Hope that helps.